All right, so here we are on Chapter 1, Ingredients of Change, Functions and Limits. This is Section 1.12 on cyclic functions and models. So a function that repeats itself with a constant input interval between the repetitions is said to be periodic, okay? So when a function is periodic and it varies continuously between two extremes, a max and a min, then the function is cyclic. And our most common one that we know of is the sine function. So what does a sine function look like? Well, it looks like this. It starts here at the, let's get my mouse here, at the 0 part, and then it goes up and down, and it just keeps repeating, and it goes both directions, up and down and stuff, and it goes between 1 and -1. So the max is 1 and up here, and the min is -1. Okay, so algebraically a sine model has the equation of the form f of x equals a times sine of bx plus c, parenthesis, then plus d. And so we have a, b, and c, a, b, c, d are constants, and a and b both have to be greater than 0. Now d, what we say here with d is it's the average value. The a here is going to be the amplitude. Now, if we take 2 pi divided by this b value, that's going to be a period. And then c divided by b is going to be a horizontal shift. Now, if it is greater than 0, we go left. And if it's less than 0, we shift right. So depending on if we have a positive or negative c, we go left or right. All right. So verbally it says a sine model exhibits cyclic behavior. It's oscillating between two extremes. And again, this can be offset, up here, so we could actually be, above, or we could even be below. We don't always have to be right on that x-axis, so cycling above and below it, okay? And that's kind of what the next one says. A sine model can appear higher or lower or stretched, but it will have the same basic shape as this figure here. Now, what about concavity? Well, if you think about this, if we have our picture here, we're going up and down like this, so that's concave down. And then this is going to be concave up. And each of these points here, that's going to be our inflection point. Then it's going to go up and down again, so that's going to be concave down and then back to concave up. So, it's oscillating between concave and up and concave down. And then we're going to be increasing from this -1 all the way up to here, a +1. It's increasing during that interval, then it decreases for the next interval, then it increases again, then decreases, and so it's kind of oscillating between increasing and decreasing. Now we kind of saw this before. If we had an oscillating function, then we had a limit was not existing, and that's the same thing here. Because sine function oscillates between two extremes, its output value has no defined limit as x increases or decreases without bound, because as we go this way, it's going to keep going up and down and up and down. So there's not going to ever be a limit. It's never going to go to positive infinity or negative infinity. It's going to be between 1 and -1 in this case. Now what about constants? So the sine function in its most basic form, which is just f of 0 equals sine of x, that oscillates between our 2 points like we're showing here, between 1 and -1. Now, each of the 4 parameters, a, b, c, and d of the general sine function, indicated change in a specific characteristic of a cycle. So, we're going to have some average value, and that's going to be, from that point all the way to the baseline. That's going to be our vertical shift, which is going to be our D. We're going to have an amplitude, that's going to be from the average value to the peak or the trough, depending on where we're at there and we're looking in. And so there's a lot of these things. A period goes from the same point to the same point, and, we could pick this point to this point, or this point over here to that one, but we don't have it. Or we could go, from here to here. So it just has to be from the same point to the same point, and that's going to be your period. Okay. So our constant d, again, is the average value or the vertical shift of the sine function. So the average or the expected value of a sine function can be calculated as the average of the two extremes. So your max plus your min divided by 2 will give you what that average is. Now the constant a is the amplitude of the sine function, and it's a measure of the difference between the extremes, again, of the output and average value. And so the amplitude is calculated as half the difference of the max min. So we'll take the max minus the min divided by 2, and that's going to be our amplitude, okay? Now the constant b is related to the period of the function. So, from here to here, or here to here. And if we had another one, we could go over here. And it's just going to be 2 pi divided by whatever our b value is in our equation, okay? Or if we need to solve for b, then we take 2 pi divided by whatever our period is. So then we have to say, okay, well, it goes from here, maybe 1 over here to maybe 4. So 4 minus 1 is 3. And so 2 pi divided by 3 would be what b is equal to if we had to solve for b. So it depends on what we're solving for. You can go either way. Now, the period of the sine function is estimated graphically by locating 2 consecutive maxes or mins or in between points, and then kind of getting that value and finding how far it is. Like I said, we could go from 1 to 4, and 4 minus 1 is 3, so that's our period. Now the constant c is related to the horizontal shift of the function, and it's going to be c divided by b if we have the sine function already presented, or we can find it by taking our b times a horizontal shift. And so depending on horizontal shift, we actually don't show it on here. Here it would be 0 because it's right on the money, so we don't have a shift. But if had maybe it had shifted to, I don't know, it's hard to draw here. Maybe it was coming up here and then down, it's shifted on a different place, then you'd have to figure out what that shift to that point is, and that's going to be part of your thing. That's your horizontal shift. Then we have to have our b, and then we could take those two, multiply them together, and get our c. Okay. Now the direction of the horizontal shift is determined by whether c is positive or negative. When c is greater than 0, again, you're going to shift left, and if it's less than 0, shift right. So a lot of times we'll see a negative, and we'll have a negative c value. Now, the magnitude of the horizontal shift of a sine model is the length of the input interval between x equals 0 and the nearest input x0, for which f of x0 is d. So we want to figure out where it's basically equal here. So maybe, it shifted over here, and that's why I said, so we're going to go up to that point if we'd shifted. And again, this is not going to be... then we come back down. Again, it's not equal on every piece here as far as the shift, but that's kind of what it is. And so then we'd have to get that point there, because we need it at the point D, and then we need to have where that x is equal to 0, because that's where our new 0 is, basically x sub 0. Okay. All right. So here's a kind of a quick example we can kind of look at to see the different things. So what we're given is we have this function, g of x equals 6 sine 1.57x minus 4.71, then plus 8. So we know that this is d, this is a, this is b, and this is c. And a is amplitude. So once we find our d, which is our 8, so we know if we go up 8 and draw a horizontal line, that is our average value, okay? And then we go from that line and can go both down or up, and it should be equal to 6. And so what we would do is we would take, okay, well, 14 minus 8 better be 6, and then 8 minus 2 better be 6 as well, and it is. And so that one works. And we'll see here in a little bit a problem in the book that's incorrect. All right, so that's what we did. 8 minus 6 is 2, and 8 plus 6 is 14. So that difference is going to give us points in between there. Now the cycle, well, remember, the period is 2 pi divided by b. So 2 pi divided by 1.57, and if you divide that out, it's 4.006 something, and so it's roughly 4. Okay, and so our period then is going to be, thinking about it, from here over here to 4, and that's kind of what it is there. Now, could we go out more decimal places? No, really can even go to 4.00, but we're going to call it 4, and that's what our period is here. Now our horizontal shift, well, that's just our c divided by our b, and it's a negative 4.7 divided by 1.57, so it's a negative 3, so that means shift right 3, and so shifting right 3, that means that is the original starting point now. So really this used to be here, but we shifted to the right 3, and then we started moving up and down, and that's how we got that. Okay, so that's kind of a quick model to kind of see where all the numbers are coming into play and helping us understand what that means. So I'll stop there, and I'll come back in a little bit.